When we think about human achievement and the relentless pursuit of knowledge, few stories capture our imagination quite like that of a small helicopter that defied all odds on the surface of Mars. This is the story of Ingenuity, a remarkable piece of engineering that was never supposed to survive as long as it did, never supposed to fly as far as it did, and never supposed to change our understanding of what is possible on another world. For 1,004 days, this tiny rotorcraft operated in conditions that would destroy most machines within minutes, pushing the boundaries of aerospace engineering and proving that sometimes the most ambitious dreams can become reality. The story begins with a simple question that engineers at NASA's Jet Propulsion Laboratory asked themselves: could we fly on Mars? This might seem like a straightforward question, but the answer is anything but simple. Mars presents challenges that make flight nearly impossible. The atmosphere on Mars is incredibly thin, about 1% the density of Earth's atmosphere. To put this in perspective, flying a helicopter on Mars is equivalent to flying at an altitude of 100,000 feet on Earth, which is more than twice the height that any helicopter has ever flown on our planet. The air is so thin that generating lift becomes an extraordinary challenge. Add to this the fact that temperatures on Mars can plunge to minus 90 degrees Celsius at night, that dust storms can block out the sun for weeks, and that there is a communication delay of up to 20 minutes between Earth and Mars, and you begin to understand why many people thought this was an impossible task. But the team at NASA was not deterred by impossibility. They began working on what would become Ingenuity in 2013, and from the very beginning they knew they were attempting something that had never been done before. The helicopter would need to be light enough to fly in the thin Martian atmosphere but strong enough to survive the harsh conditions. It would need to generate enough lift to overcome Mars's gravity, which is about 38% of Earth's gravity. It would need to be autonomous enough to fly itself, because the communication delay meant that no human pilot could control it in real time. And it would need to survive temperatures that would freeze most electronic components solid. The solution was a masterpiece of engineering. Ingenuity weighs just 1.8 kilograms, about the same as a laptop computer. Its body is roughly the size of a box of tissues. But mounted on top of this small body are two sets of carbon fiber rotor blades, each measuring 1.2 meters from tip to tip. These blades are designed to spin in opposite directions at an incredible 2,400 revolutions per minute, which is about 5 times faster than a helicopter rotor on Earth. This rapid spinning is necessary to generate enough lift in the thin Martian atmosphere. The entire contraption stands about half a meter tall, making it small enough to fit underneath the Perseverance rover during the journey to Mars. Inside this tiny frame, engineers packed an array of sophisticated technology. A solar panel sits on top of the helicopter to recharge its batteries during the Martian day. A heating system keeps the electronics warm during the freezing Martian nights, consuming most of the energy stored in the batteries. 2 cameras are mounted on the helicopter, one pointing downward for navigation, and one pointing forward for terrain observation. A small computer, similar to the processors found in smartphones, serves as the brain of the operation, running the complex algorithms needed for autonomous flight. And a radio system allows the helicopter to communicate with the Perseverance rover, which then relays messages back to Earth. When Ingenuity arrived on Mars in February 2021, tucked beneath the belly of the Perseverance rover, nobody knew if it would even survive its first night. The mission was designed as a technology demonstration, with a planned duration of just 30 days. The goal was simple: attempt 5 flights over the course of a month to prove that powered flight on Mars was possible. If Ingenuity could do that, it would be considered a success, and the team could move on to designing more capable aircraft for future missions. But Ingenuity had other plans. The first flight took place on April 19, 2021, and it was a moment that will go down in history alongside the Wright brothers' first flight at Kitty Hawk. Ingenuity lifted off from the Martian surface, rose to an altitude of 3 meters, hovered in place for 30 seconds, made a small turn, and then landed safely back where it started. The entire flight lasted just 39 seconds, but those 39 seconds proved that humanity could fly on another world. The data streamed back to Earth, and when the team saw confirmation that the flight had succeeded, there were tears and cheers in the control room. Ingenuity had done what many thought was impossible. But this was just the beginning. The second flight went even better, with Ingenuity rising to 5 meters and performing more complex maneuvers. The third flight pushed further, with the helicopter traveling 50 meters downrange before returning to its starting point. The fourth flight was even more ambitious, flying for nearly 2 minutes and covering a distance of over 250 meters. And the fifth flight, which was supposed to be the final demonstration, saw Ingenuity climb to 10 meters altitude and fly 129 meters to a new landing site, demonstrating its ability to scout terrain ahead of the rover. At this point, the 30-day technology demonstration was complete. Ingenuity had exceeded all expectations, but the helicopter was still functioning perfectly, and the Perseverance team realized they had a valuable asset on their hands. Rather than ending the mission, NASA made the decision to extend it. Ingenuity would transition from a technology demonstrator to an operational scout, flying ahead of Perseverance to identify interesting geological features and help plan the rover's route. This was never part of the original plan, but it opened up entirely new possibilities for Mars exploration. Over the following months and years, Ingenuity continued to fly mission after mission. Each flight brought new challenges and new achievements. The helicopter flew over terrain that would have been dangerous for the rover to cross, providing aerial reconnaissance that saved the Perseverance team valuable time. It captured stunning images of the Martian landscape from perspectives that had never been seen before, giving scientists new insights into the geology of Jezero Crater. It tested the limits of its design, flying higher, faster, and farther than it was ever intended to go. By the time Ingenuity reached its 100th Sol, or Martian day, on Mars, it had already completed 7 flights. By Sol 200, it had flown 14 times. The flights became more ambitious as the team gained confidence in the helicopter's capabilities. Ingenuity began flying over rougher terrain, navigating around obstacles and covering greater distances. On its 25th flight, it set a new altitude record, climbing to 18 meters above the surface. On its 62nd flight, it flew for over 150 seconds, covering more than 600 meters of distance. But operating on Mars is never easy, and Ingenuity faced numerous challenges throughout its extended mission. The changing seasons on Mars brought new problems. As winter approached in Jezero Crater, the amount of sunlight hitting Ingenuity's solar panels decreased, reducing the amount of energy available to charge the batteries. The helicopter's computer was programmed to shut down overnight to save power, but on several occasions the batteries dropped so low that the helicopter reset itself, losing track of time and its position. The team had to develop new procedures to recover from these resets and get Ingenuity flying again. Dust storms posed another threat. Mars is famous for its global dust storms, which can block out the sun and coat everything in fine dust. Dust accumulation on Ingenuity's solar panels reduced their efficiency, making it even harder to generate enough power. The team had to carefully plan each flight to ensure the helicopter had enough energy to survive the cold Martian nights after landing. There were times when flights had to be postponed because the conditions were simply too risky. The terrain itself presented challenges. Jezero Crater is an ancient river delta, and the landscape is littered with rocks, dunes, and slopes that make navigation difficult. Ingenuity's navigation system relies on its downward-facing camera to track features on the ground and determine its position. But over featureless terrain like sand dunes, this system can become confused. The helicopter had to be programmed to recognize when it was over difficult terrain and adjust its flight accordingly. Despite these challenges, Ingenuity continued to perform remarkably well. As the mission progressed, Ingenuity broke record after record. It became the first aircraft to fly on another planet multiple times. It logged more than 2 hours of total flight time, which might not sound like much, but remember that every second of flight on Mars requires overcoming immense technical challenges. It traveled a total distance of over 17 kilometers, far exceeding what anyone thought possible. It climbed to altitudes that pushed the limits of its design, and it captured thousands of images that helped the Perseverance team navigate the Martian surface more efficiently. The helicopter also contributed to scientific discovery in unexpected ways. While Ingenuity was not designed as a science mission, its aerial perspective provided valuable data about the geology of Jezero crater. The images it captured helped scientists identify interesting rock formations, understand the distribution of different materials across the landscape, and select targets for Perseverance to investigate. In some cases, Ingenuity spotted features from the air that would have been impossible to see from the ground, leading to new insights about Mars' ancient past. Perhaps most importantly, Ingenuity demonstrated that aerial exploration is not just possible on Mars but highly valuable. Before Ingenuity, Mars exploration was limited to orbiters flying overhead and rovers crawling along the surface. Orbiters provide a broad view but lack detail. Rovers provide detailed observations but can only cover limited distances. Ingenuity filled the gap between these two extremes, offering a middle ground that combined good spatial coverage with reasonable image resolution. This capability proved so useful that NASA is now planning more advanced aerial vehicles for future Mars missions, including larger helicopters and even airplane-like drones. The engineering lessons learned from Ingenuity are equally valuable. Every flight provided data about how aircraft perform in the Martian environment, information that will be crucial for designing the next generation of Mars helicopters. The team learned how to deal with the thin atmosphere, how to manage power in the extreme cold, how to navigate autonomously in challenging terrain, and how to recover from unexpected problems. These lessons will make future missions more capable and more reliable. But beyond the technical achievements and scientific contributions, Ingenuity captured something intangible but equally important: the human spirit of exploration. Every time the little helicopter took to the Martian skies, it reminded us that we are a species that refuses to accept limits. We are builders and dreamers who look at impossible challenges and ask not whether we can overcome them, but how. Ingenuity embodied this spirit in every flight, every image, every successful landing. For 1,004 days, Ingenuity operated on Mars, far exceeding its design lifetime of 30 days. It completed 72 flights, each one a testament to the ingenuity and dedication of the team that built and operated it. It traveled over 17 kilometers across the Martian surface, scouting terrain and capturing images that will be studied for years to come. It survived dust storms, temperature extremes, and equipment failures that would have ended most missions. And it did all of this while being controlled by a team on Earth that could only send commands and then wait nervously to see if they worked. But every mission must eventually come to an end, and Ingenuity's story is no exception. In January 2024, during at would be its 72nd and final flight, something went wrong. The helicopter was attempting a short vertical flight, a simple maneuver it had performed dozens of times before. But this time, contact was lost during the descent. When communications were finally re-established, the data showed that Ingenuity had landed hard and sustained damage to its rotor blades. Images captured by the Perseverance rover showed that at least one of the blades had broken off completely, making future flight impossible. The exact cause of the crash is still being investigated, but the leading theory is that Ingenuity flew over terrain that lacked sufficient features for its navigation system to track. Without good visual references, the helicopter may have become disoriented during landing, causing it to tilt and strike the ground with its rotor blades. It was a reminder that even after 3 years of successful operations, Mars remains an unforgiving environment where a single mistake can end a mission. The loss of Ingenuity was bittersweet for the team and for everyone who had followed its remarkable journey. On one hand, it was sad to see such a capable machine come to an end. On the other hand, Ingenuity had already accomplished far more than anyone had dared to hope. It had proven that powered flight on Mars is not only possible, but practical. It had provided invaluable data for future missions. It had inspired millions of people around the world with its achievements. And it had shown that sometimes the most audacious ideas, the ones that seem impossible at first, can succeed beyond our wildest dreams if we have the courage to try. Today, Ingenuity sits silent on the surface of Mars. Its flying days over, but its legacy secure. The data it collected will inform aerospace engineering for decades to come. The images it captured will help scientists understand Mars's geology and history, and the inspiration it provided will motivate the next generation of engineers and scientists to push the boundaries of what is possible. Future missions to Mars will almost certainly include aerial vehicles, and when they do, they will owe their existence to the tiny helicopter that proved it could be done.